plus a 15 is going to give us a 13. Okay. It's 1 plus 3 times minus 2, so it's 1 plus minus 6 gives us a minus 5. It's 0 plus 3 times minus 1 gives us a minus 3. Okay, so we're nearly there. The next thing we should do is we should get a 0 above the 1 in the first row, or a 0 in this position here. And what we can hopefully see is that if we add on, or if we take away 3 times row 3 from row 1, that should result in a 0 here. So what we're going to say is that row 1 is going to become row 1 minus 3 times row 3. Okay. So in this situation, the row to change is row 1. So the other rows remain the same. So we have 0, 1, 0, 13, minus 5, minus 3, 0, 0, 1, 5, minus 2, minus 1. Okay. And it's row 1 that's been updated. So row 1's new value is equal to the old value minus 3 times row 3's value. So the first value to go in here is going to be row 1's value, which is 1, minus 3 times 0 gives us a 1. The next value is going to be 2 minus 3 times 0 gives us a 2. The next value is going to be 3 minus 3 times 1 gives us a 0. The next value is going to be 1 minus 3 times 5. Well, minus 3 times 5 is minus 15. Plus the 1 gives us minus 14. Okay. And then we have 0 minus times minus is a plus. 3 times 2 is 6. So we have 0 plus 6 gives us a 6. And then we have 0 plus minus 3 times minus 1 is a plus 3. So it's a 0 plus 3 gives us a 3. Okay, so we're nearly there. Okay, the only thing that we need to do now is we need to convert this 2 here into a 0. Okay, well, why don't we add on multiples of the second row to the first row? Okay, because the 0 won't have an effect here, the 0 won't have an effect here, but the 1 will have an effect here. So what we're going to say is that row 1 becomes row 1 minus twice row 2. Okay, so the only row to change is row 1. So our matrix is going to be 0, 1, 0, 13, minus 5, minus 3, 0, 0, 1, 5, minus 2, minus 1. That's our matrix. Okay, our augmented matrix. And row 1 now becomes, well, it's the old value in row 1 minus twice row 2. So it's 1 minus twice 0 gives us a 1. It's 2 minus twice 1 gives us a 0. It's a 0 minus twice 0 gives us a 0. Okay. Now it's minus 14 minus twice. Okay. So minus 14 minus twice 13. Well, minus twice 13 is minus 26. So we have minus 14 minus 26 gives us a minus 40. Okay. The next value is going to be 6 minus times minus is a plus. 2 times 5 is 10, so it's going to be a 6 plus a 10 gives us a 16. And then finally we have a 3 minus times minus is a plus, so we have a 3 plus a 6 to give us a 9. Okay. So what we've done now is we've reduced our matrix. Okay. Our original matrix, through elementary row operations. Okay, we've reduced this matrix down into the identity matrix. And this particular process, the result is that this matrix here, is the inverse of our original matrix. And maybe what we need to do now is we need to verify that this is in fact the inverse of this matrix. Okay, so maybe we'll have a look at that now next and do this pretty quickly. Okay, so our original matrix A, is 1, 2, 3, 2, 5, 3, 1, 0, 8. And our reduced matrix is minus, so let's call this B, is minus 40, 16, 9, 13 minus 5 minus 3, 5 minus 2 minus 1. And the question we're being asked is this matrix B the inverse of this matrix? Well, if B is A's inverse, well then A times B should be equal to the identity matrix, or B times A should be equal to the identity matrix. So we have a quick test that we can do. If we multiply the A by the B, we should end up with the identity matrix. So let's do that. Either way, this should work, and maybe to verify you need to do both ways. But let's just take the first way where we have 1, 2, 3, 2, 5, 3, 1, 0, 8, and we're going to multiply that by minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. What we have here is we have a 3 by 3 matrix and we have a 3 by 3 matrix, so the result is going to be a 3 by 3 matrix. Okay. To do this now, just keep in mind matrix multiplication. Maybe you can have a look at one of the previous videos in relation to matrix multiplication. The resulting matrix, which is going to be a 3 by 3 matrix, the entries, are the result of the row times the column. So this particular entry that's going to go in here, we're going to have 1, 2, 3 entries. 1, 2, 3. 1, 2, 3. This entry is on the first row, first column. So what we should do is we should take the first row and multiply it by the first column. Okay, and that should give us our value. So the first row times the first column will be 1 times minus 40 gives us a minus 40. 2 times 13 gives us a 26. 3 times 5 gives us a 15. So we have 26 and 15 gives us 41. Minus the 40 gives us a value of 1. Okay. The next entry in here, well, this particular entry here is on the first row, second column. So what we need to do is we need to multiply the first row by the second column. Okay. So we have 1 times 16 gives us a plus 16. We have 2 times minus 5 gives us a minus 10. We have 3 times a minus 2 gives us a minus 6. So the minus 10 plus the minus 6 gives us minus 16, plus the 16 gives us a 0. Okay. The entry in here is on the first row, third column. So we need to multiply the first row by the third column. Let me actually do this out. So it's the first row times the third column. So it's 1 times 9 plus 2 times minus 3 plus 3 times minus 1. Okay, well, what's that give us? That gives us a 9. That gives us minus 6 minus 3, which gives us a 0. So we have a 0 in here. Okay. This entry in here, okay, is on the second row, first column. So what we should do is we should multiply the second row by the first column. Okay, so the second row by the first column, entry by entry, is 2 times minus 40. So it's 2 times minus 40 plus 5 times 13. 5 times 13. Plus 3 times 5 plus 3 times 5. Okay, so 2 times minus 40 is minus 80. 5 times 13 is going to be 65. 3 times 15 is 15. 65 and 15 is 80. And minus 80 gives us a 0. So we end up with a 0 here. And if we continue in this particular fashion, the entry in here is on the second row, second column. So we multiply the second row by the second column. What we'll arrive at is a 1. The entry in here will be a 0, 0, 0, 1. If you do the calculations yourself. And what we end up with is, we end up with the identity matrix. Okay? So what we know now is that this matrix B is the inverse of A. So we have that this is A, and this matrix here is A inverse. Okay? So guys, I hope that particular video, or that short video, demystified what's involved in relation to finding the inverse of a matrix. Once again, what we do is we augment our matrix with the identity matrix. We perform elementary row operations so that we reduce our original matrix down into the identity matrix. The augmented matrix that's associated with this identity matrix by definition is the inverse of our original matrix. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. Thank you.